So if we now look at some aspects of clouds as a service and platform model, this defines these various levels: infrastructure as a service, which is set up on terms of a hosting platform, a bunch of computers. And this allows you to take that hosting platform and use it to host, to be viewed as a set of virtual resources, either clusters or computers or storage and network. And you have to manage those. That's what things like Eucalyptus and OpenStack do. And then we have the cloud platform as a service, which are the system capabilities such as databases of various types and processing, MPI, MapReduce, and so on. We have security services. I've already stressed management. We need to automate all of this. That's what's built around these systems like OpenStack. And of course, what we care about for our problem here is cloud applications, which are software as a service. Here is Microsoft's view of infrastructure as a service, which is set up with virtual machines. The virtual machine has access to local and shared data storage. It has an IP address visible to the world. And there's a fabric controller, which is not terribly well documented how to build a fabric controller, because that's very proprietary. And obviously Amazon and Microsoft and Google, etc., are probably not going to tell you all the nitty-gritty details of why they have such great fabric controllers. This is basically the thing that makes all this work. Here is yet another layered diagram of the physical, the virtual, the infrastructure as a service, the platform as a service, and the software as a service. We've seen that description possibly less elegantly on previous slides. And here we have this picture I've shown before, software as a service down to network as a service, and points out that this is relevant for clouds, but also works for particular ordinary clusters. If you have a cluster, you're actually going to set it up in this fashion. Your software as a service is your applications, your platform as a service is your system, your infrastructure as a service is your hypervisor, your bare metal. We would actually view both of those run simultaneously. That's what FutureGrid does. And that's where Nimbus, Eucalyptus, OpenStack, OpenNebula, CloudStack, and VMware sit. And then at the network level, we have OpenFlow providing network as a service. And we look at these different technologies. OpenStack is probably the dominant open source technology at the moment. Eucalyptus was the first major one. Nimbus was an important technology, which, for instance, FutureGrid is developed significantly and used to run many of its services. We have OpenNebula as the dominant technology in Europe, and CloudStack, which is essentially a breakaway from OpenStack. And these all offer similar capabilities. Actually, if you just go to OpenStack, you'll see they offer lots of different capabilities with different sub-projects. There's a networking project and an interface project and this compute project and the storage project. And that's why I say they're separable ideas. And you install on your own clusters, and you have control over their operation. And that compares with the public clouds, which where the operation is opaque. You just need a credit card and a web browser, but you're not quite certain what's happening. And for instance, you can't do reproducible work. And presumably the commercial versions like VMware provide similar capabilities, but with better support and greater robustness. It's well known that, say, PayPal is just switching from VMware to OpenStack, but PayPal is owned by eBay, which has lots of internal expertise. So a company like that can well adopt these open source technologies and not need the dedicated support of that VMware has. Eucalyptus is an example of a system which has both open source and commercial versions. We've seen this X as a service slide before. We have software as a service, built on infrastructure as a service and platform as a service, and it provides research as a service with which is cyber infrastructure. So platform as a service and provides the systems, software that enable you to build lots of nifty applications. And software as a service is what you want, which is the online delivery of applications. I pointed out that these software as a service services either act with the user, that's via the from the browser, or they interact with other applications, other services, and you use technology called workflow to link all these services provided the software as a service together, so we can get our complete pipeline from the raw data through the sophisticated knowledge and wisdom and policy and decisions with some arbitrary number of services linked together, doing greater refinement of the original raw data through the DIKW stages. Here we have the slide we've seen before of the growth in these areas, pointing out that actually infrastructure as a service is meant to grow most rapidly according to Gartner, followed by platform as a service, and then software as a service. And I pointed out before, and that slightly surprised me. I would have expected software as a service to have the greatest growth, because it corresponds to more and more applications, and that's what I would have guessed. But maybe we have more applications where they're using the same services, so we don't grow the software as a service part quite as much. But we do grow infrastructure as a service because we want to run bigger and bigger applications, or more and more applications.